So we're starting 9.4, day 1 today, and then we'll do day 2, and then we'll do day 3. We're going to spend pretty much all week on 9.4. Our objective today is just to simplify rational expressions. Does anybody remember how to simplify fractions? Nobody knows how to simplify a fraction? That's sad. That's pretty much what we're doing. It's just like the next level. All right, the notes is a little long, but then once we're done with them, we just do examples the rest of the time, so it's not so bad. A rational expression is in simplest form when its numerator and denominator are polynomials that have no common factors or no common divisors. If the numerator and denominator are monomials, then simplify what you can. Kind of just like simplifying a fraction. If the numerator and denominator are binomials or larger, you must first factor both. So this is why we reviewed factoring for a while there. So on that very first example, do we have monomials or binomials or polynomials? Monomials on the top and the bottom. That is the easiest situation, is if you've got monomials on top and bottom. Now it's monomial because it's just one term. It's not getting split up with a bunch of addition and subtraction in between the numbers or the variables. So we just simplify it like a fraction, one piece at a time. Really, we've done stuff like this before. You can put a fraction bar right away if you would like to. You don't have to. So we've got negative 27 divided by 9. Negative 3. It would be negative 3 over 1. If you want to put the 1 in the bottom, you can. You don't have to. With x cubed divided by x to the 4th. X will go on the bottom, and its exponent would be a 1. So we put the x to the first power. If you want to write the first power, you can. It goes on the bottom because our rule for simplifying or dividing exponents with the same base, powers with the same base, we subtract the exponents. So 3 minus 4 would give us what? A 1, but it would be negative. So it would start out on the top, and then we would push it down to the bottom to make it positive. Oh, yeah. The other way to think about it, and how my Algebra I class remembers it, is wherever the bigger exponent starts is where the positive exponent ends up. So the bigger exponent was in the denominator. That's where x will have a positive exponent in the end. Does that make sense? Okay. Then what happens with our y's? They cancel out. So they just are gone completely. So we have negative 3 over x as our final answer. On number 2, do we have a monomial or binomial, polynomial? Monomials top and bottom. That's my favorite situation because I don't have to factor. I can just simplify. So I like to go ahead and make my fraction bar right away and then decide if things are going to go on the top or the bottom. So I look at things one part at a time. If I just look at the numbers, 12 over 36. Good. As a fraction, that reduces to 1 over 3. A squared divided by a. The top gets an a to the first, so 2 minus 1 is 1. It was bigger in the top. Exponent was bigger in the top, so the a goes in the top. B divided by b to the 4th.
B to the 3rd.
Good. B to the 3rd in the denominator. So 4 minus 1 is 3. started off bigger exponent in the denominator. That's where it belongs. C cubed divided by C squared. C to the first in the top. That's it. That's all there is to it. We simplified everything we could. If you did not have a 1 out in the front on the top, that's okay. You can just have a C. If you kept the 1, that's also fine. Either way, it's the same thing. Questions, concerns? All right, number 3. Are they monomials? No, they are binomials, which means that before we can start simplifying it, we have to first factor. So when we factor, what's the first thing we should always look for? A GCF. Do I have a GCF in the numerator? 2. And when I factor out a 2, what's left? X minus 3. Now we're going to pause there. Are we all okay with how we factored out a 2? Normally we would write it underneath and divide it out, but we just wrote it out in front of parentheses and what was left over inside the parentheses. What about a GCF of the denominator?
3x minus 3.
A 3, and then what's left over is the x minus 3. Again, normally in the past we would have shown a little bit more work with that, but we should be more confident in factoring out a GCF. Do we have questions about it? Okay, then our next step is to simplify. So what could cancel out here?
X minus 3.
Good. Those sets of parentheses match perfectly top and bottom, so they cancel out, and what are we left with for an answer? 2 over 3, 2/3. Leave it like that. Do not try to put it into a decimal. Just leave it alone. All right, number 4 in the top, what do we have? Monomial, binomial, binomial, but the bottom is a monomial. So the numerator we're going to have to factor. The denominator isn't going to change right away. There's nothing to factor from a monomial. What could we factor from the binomial in the top?
3.
A 3? C, good. They both can be divided by 3 and C. That's convenient. What's left?
2C plus 3.
Good. 2C, I'm running myself out of room, plus 3. So we took a C from both terms, which C squared, take away 1C, leaves you with a C. In the back, we took away the only C, so it's just a number now. What's going to cancel out this time? The 3 C's cancel out top and bottom, and what are we left with? 2C plus 3. If you want to leave it in parentheses, you can, but since that's the only thing that's there, we can drop the parentheses if you want to. Number 5. What are we working with in the numerator? A binomial, and then the denominator, a trinomial. So in either of them, the first thing we should check for is a GCF. Do we have a GCF in the numerator? What is it?
3.
A 3. I would recommend taking out a -3 just because they're both negative terms. And we like what's in parentheses to start off with a positive if we can. So what do we end up with in there? 2 plus x. Okay, so we took out a -3 from both of those and made both terms inside positive. We also divided both parts by a 3. In the denominator, remember these ones factor into 2 sets of parentheses. Good. X minus 4, x minus 2. If you need to, remember last week we talked about how some of you might have learned in Algebra 1 to use this x method, where we have to multiply to an 8 and add up to a -6. And the numbers that do that are -4 and -2. If you didn't learn this here, or you don't like it, or you don't have to use it, but it helps some people organize their thoughts. Questions? Okay, so then we have to think about, is anything going to cancel out here? No. Okay, so even if we were to rearrange this, the x and the 2 are both positive. Down here, the x is positive, but the 2 is negative. So, yeah, I would just leave this as your answer. There's really nothing more we can do, but we showed that we tried to simplify it, but none of the factors canceled out. Questions, concerns about it? Okay. If we had factored out a positive 3 here, just by the way, then both the 2 and the x would have been negative. So it's important to know that no matter how we factored out the top, it would not have matched the signs on the bottom. Okay, there's no way we could have made it work out. Let's take that one away and bring back number 6. And we'll just get rid of number 5. All right, on number 6, in the numerator, we have a binomial. Is there a GCF?
2.
Yes, it's a 2. I'm going to write this one below just so I've got enough space. What's left when I factor out a 2 from the numerator? The x plus 5. Good. Remember, we always write our GCF outside the parentheses. Don't leave it off, otherwise that'll mess with your answer later. Someone is very excited about the fact that we can factor out the denominator nicely. What do we get? X plus 5 and x plus 5. Remember, if you use that x method, we're multiplying to 25, adding up to 10. 5 and 5 do the trick. Now, will something cancel here? What?
The x plus 5.
All of them?
No, just one.
No, one from the top and one from the bottom. It doesn't really matter to me which one from the bottom you cross out. But just one from the top, one from the bottom, not all of them. So what are we left with for an answer?
2 over x plus 5.
Good, 2 over x plus 5. Again, if you want parentheses around your x plus 5 in the denominator, you can put them there, but they are not necessary at this point. All right, on number 7, in the numerator, we have a
GCF.
No,
a monomial.
what?
All right, in the numerator, we have a monomial, which means we're just going to leave it alone. In the denominator, we have a,
Triangle.
nope,
Binomial.
binomial, 2 terms. So we check for a
GCF.
GCF, which is 2x. And what's left over when we factor out 2x? 2x minus 1. Remember, if you divide something by itself completely, what's left over is a 1. Are we okay with that? All right. What cancels? Okay. Now this is where we have to be careful. What am I left with? Good. 1 over whatever's left in the bottom, which in this case is a 2x minus 1. If whatever's in your numerator cancels out completely, there's still a 1 up there as a placeholder.
So we would get it wrong.
So you would get it wrong if you just wrote 2x minus 1. It's got to be 2x minus 1 in the denominator with a 1 in your numerator. Just because our numerator canceled out doesn't mean our fraction disappeared. Questions about number 7? Ready to bring back number 8?
C.
Yes, sir.
Is this how the quiz is? This is new?
This is new.
Yes.
New notes.
The quiz is over 9.1 in factor.
Sadia is correct. So we are using some of our factoring skills that we quizzed over last week. But this material is technically new. All right, let's bring back number 8. Actually, I'm just going to start this slide fresh. There we go. And take away 7, so I've got some room to work off to the side here. All right, in the numerator and the denominator, I have trinomials, which, again, if you liked that X method that often gets taught in Algebra 1 here, we've already done technically this numerator, 25 in the top, 10 in the bottom. What goes on my sides? 5 and 5. Good. So my numerator turns into x plus 5 times x plus 5. Okay. X plus 4, x plus 5. Now just as a quick refresher, in case you're wondering where we came up with that denominator, if we were to make the x method for the denominator, we're multiplying to 20 and adding up to 9. So 4 and 5 is what does that for us. What cancels out? Okay, we can cross out a pair of x plus 5s, and we are left with? Good, x plus 5 over x plus 4. Again, if you want to keep those in parentheses, you can, but it is not necessary if there's nothing else outside of them. How are we going to factor that numerator?
B minus 1, B plus 1.
Good, it's the difference of two squares. So we have b minus 1 times b plus 1. All of it over b minus 1. So what cancels out? The b minus 1s, and we're left with b plus 1. Do I have to write it as a fraction?
No.
No. If your denominator goes away completely, that's different than when your numerator goes away completely. So if you wanted to put it over 1, you can, but if the 1 is in the denominator, it's not essential. It's an option. Questions before that disappears and we put up number 10? Okay. Let's see. I'm going to give you a couple minutes to work on 10, 11, and 12, and we'll talk about the answers in just a minute. Bring it back. All right. We left off with number 10. How does the numerator factor? Good. Z plus 7, Z minus 7, which means what cancels out? The Z plus 7. Now notice, even though they didn't put their Z plus 7 in parentheses, it still cancels out with our Z plus 7 in the numerator. And what are we left with? Z minus 7. If you want to put it over 1, you can, but you do not have to. All right, I'm going to erase number 9 so I can show my work for 11 above it. Did the numerator factor?
Yeah.
What did we get?
X plus 4.
Good, x plus 4 times x plus 4. When we factored out that numerator, x squared plus 8x plus 16. And when we factored the denominator, x plus 4, x minus 6, I would agree. 4 and negative 6 multiply to negative 24 and add up to negative 2. What cancels out? X plus 4 and x plus 4, top and bottom. What are we left with?
X plus 4 minus
Good, x plus 4 over x minus 6. Now, please remember that even if I drop the parentheses, I cannot cancel out those x's. I cannot reduce the 4 and the minus 6. If you need to keep those in parentheses to remember that they are a group and you cannot just break them up that way, leave them in parentheses. Does that make sense? Because I get students that get just a little too cozy with this and then they start crossing off things that they should not be canceling out. Questions, concerns? Okay, don't take it too far. Just stop when you're supposed to. All right, I'll take away 10 so I can show my work for 12. How did the numerator factor?
X minus 8x plus 3.
Do we agree with x minus 8x plus 3?
Yes.
Good. And the denominator? X minus 10x plus what? 3. Good. So what cancels? The x plus 3's cancel out. What are we left with?
X minus 8 over x minus 10.
X minus 8 over x minus 10. Remember, even though I didn't write those parentheses, I cannot cancel out the x's or reduce the 8 and the 10. If you need to leave them in parentheses to remember not to try to cancel anything else, just leave them in parentheses. Questions, concerns? Ready for a little more practice? 2 more. They're going to be fun ones. We'll do them one at a time.
Oh my god.
What's different about 13?
You got two in front of the x squared.
We got 2 in front of the x squared, which means we can't just use the x method.
Bottoms up.
We got to use bottoms up,
What's the other one?
or we'll talk about bubbles. If anybody remembers using the bubbles method.
That's freshman year. Like
That was a freshman year, yes.
I don't remember like the beginning, but I remember.
Oop, that's not what I wanted.
Don't that be like straight across?
We'll talk about it. We can talk about it both ways. So, if you remember bottoms up and you like bottoms up, you want to do bottoms up, that's fine because that's how we did it first semester. However, we're going to also talk about how you would have most likely learned to do these freshman year if you went here for your freshman year. And you can decide if you want to go back to freshman year's way or use bottoms up. So if we are just factoring the numerator, we should always check for what first?
GCM.
A GCF, but there isn't one. Sad.
1.
So, if we're going to do the bubble method, we have to think about what our signs are and what we're looking for. And we're going to create bubbles, really they're just little circles, that have factors of the leading coefficient, so the number out in front, and factors of the number in the back. So, what are our only options for factors of 2? 1 and 2. So the bubble for the front is going to have to be a 1 and a 2. Now the bubble in the back, if we're making a negative 2, one of our numbers will be negative and one will be positive. And we have to decide which one's going to be which. Now for example, if I make the 1 a negative and put a 2 on the bottom, and then we kind of connect our bubbles, when we connect them, we multiply those numbers that we connected. Now, I don't know, this is not going to turn out right. I'll tell you that right now. So you might just want to watch this one, and then we'll change it to make it the right bubbles. 1 times negative 1 is negative 1. 2 times 2 is 4. And when I combine those, I get
1, 4.
a 3.
Oh, what?
If you combine a negative 1 with a 4, it's kind of like adding them. Combine them, you get a 3. Now, why do I know that that's not what I want?
There needs to be a negative.
It needs to be a negative 3. We want the number that's in the middle. So, what do you think I need to do with my second bubble?
Negative.
Add another negative.
Add another negative?
Which is negative 2.
Make the 2 a negative and the 1 a
Positive.
positive. So, let's just take all that away. We'll make the 1 the positive and the 2 the negative. So, now 1 times 1 is
1.
2 times negative 2. Negative 4. When we combine them, we get a negative 3. So that's what we want. And so this helps us be able to factor just the numerator. So in the numerator, what gets a little tricky here is how we set up our parentheses now. So in the front, I'm going to use my first bubble. That's going to help me with the front of both parentheses. So I have a 1x in the front and a 2x in the other front. When we go to fill in the backs, we kind of flip-flop what was connected. So the the 1 was connected to a 1. So in parentheses with the 1, I'm going to put the other thing,
-2.
the -2. And in the other parentheses, that only leaves me one option. I gotta put a +1. Does anybody remember doing this method freshman year? Oh dear. All right. So if you remember bottoms up and that's how you prefer to do this, that's fine. I like this method. There's another method I like even more, but we never even talked about it, so we won't go there. Are we okay with the numerator for right now? Okay. Then in the denominator, this one will factor just like some of our last ones would, where we could use the x if we want to. What will the denominator factor into? Good. X minus 3, x minus 2. Those numbers multiply to a +6, add up to a -5. What cancels out? X minus 2's cancel. So we're left with 2x plus 1 over x minus 3. Again, don't try to cancel anything out here. That's as simple as it gets. You can leave them in parentheses if you need to. So on your notes, if your variable on your 8 does not match, go ahead and make it a y so that all of our variables are y's. Now, in both the numerator and the denominator, what should we be looking for before we get started? A GCF. And do we have one?
2.
Yes, we've got a GCF of a 2 in both the numerator and in the denominator. So in the numerator, what's left over when we factor out a 2? Y squared plus 4y minus 12. Good. And what about in the denominator?
2 and then y squared minus 4y plus 4.
Beautiful. Are we okay with factoring out just our GCF? Okay, now you could go one of two ways with this. You could just leave your GCF alone while you keep factoring. Or, what do we notice about our GCFs? They cancel each other out. So if you want to go ahead and cancel them out right now, you can do that. If you want to wait till later, that's fine. But at some point, our GCFs are going to cancel, so we might as well do it now. But then we're not necessarily done, because we should check to see if we can factor what's left in both the numerator and the denominator. So in our numerator, can we factor y squared plus 4y minus 12?
Yes.
What does it factor into?
Y plus 6, y minus 2.
Good. Y plus 6 and y minus 2. So now that we got the GCF of a 2 out of there, we don't have to worry about doing bottoms up or bubbles or anything like that. In the denominator, will that factor? The answer is yes. So what will it factor into? Good. Y minus 2, y minus 2. Now what cancels out? A set of y minus 2's from top and bottom. And we are left with y plus 6 over y minus 2. Now I promise you, I'm going to have people on the test that then tell me that that equals -3. Don't be that person.
Y'all better listen.
Okay? The y's cannot cancel. The 6 and the minus 2 cannot cancel. If you need to leave those in parentheses so that you remember you can't break them apart, just leave them in their parentheses.